Hi, Algebra 2. In this video, I'm going to be doing 4 different examples of solving rational equations. I actually pulled these examples right from the Delta Math, so they should be really similar to the problems you have to do. The first 2 examples are from the first section of the Delta Math, which is rational equations level 1, and then the third and fourth examples are from solving rational equations with the least common multiple or least common denominator. So I have our steps on the left side. Our first step is always to determine the least common denominator of the terms. So what I think about is, what do I want to multiply each term by that would cancel out all of the denominators? So when I look at this example, 2 over x plus 6 plus 3 equals x over x plus 6. I want to look at what different denominators I have. I have the denominator x plus 6, and then I have the denominator x plus 6 again. So since I only have one denominator, my common denominator is just x plus 6, okay? If I had different denominators, I'd have to work a little harder, and we'll talk about that, but if the only denominator I see is x plus 6, then that's what I'm going to multiply all of my terms by with my least common denominator. So step 2 says actually multiply each term by the least common denominator in order to cancel them out. So I'm going to multiply every single term by x plus 6. You can't forget to multiply any of them. Remember, we always have to do the same thing to every term. So now I've multiplied all my terms by x plus 6, and that's perfect because I'm going to cancel out in the first term. That cancels out my entire denominator, which is exactly what I wanted. I want to be able to solve this equation without having any more denominators. My second term doesn't have a denominator, or it has a denominator of 1, so nothing cancels out. And then my last term, the x plus 6, cancels out again. That's exactly what we wanted. Now we just need to write down what we have left. So with my first term, since the x plus 6 canceled out, I'm left with 2, and then plus. In the next term, we didn't have anything cancel out, so I have 3 parentheses x plus 6. And then on the right side of my equal sign, my denominator canceled out, so I'm just left with my numerator of x. Now we're in step 3, which is distribute and combine like terms if necessary. I do have some distributing I can do. Distribute the 3 to the x and to the 6. So I'm going to have 2 plus 3 times x gives me 3x, and then 3 times 6 gives me 18. All right, and then I do have like terms here. My 2 and my 18 can be combined to give me 20 plus 3x equals x. Now, step 4, solve for x using the inverse operations. So I usually try to get all my x terms on one side and all my constant terms on the other side. So I'm going to want to move the 3x. Now I would move the x to the left side, but then I'm going to have 0 on the right side, which is just going to take me a little longer. So I want to just subtract the 3x. I want to avoid having 0 on one side because then I'm going to have to move my constant term as well. So it kind of adds an extra step, but you could do it that way. I'm going to subtract 3x from both sides. So then I have 20 left on the left side, and then x minus 3x, that's 1x minus 3x, so that gives me negative 2x. And then my final step would be to divide both sides by negative 2 to solve for x. So I'm going to have 20 divided by negative 2, that's negative 10. And then I'm left with x on the right side. So that's my solution. Now, step 5 is to identify if I have any extraneous solutions. I want to think back to my original equation and think what value of x would have been extraneous. So since my denominator is x plus 6, I'm thinking what value of x would cause a 0 in the denominator. So what would I have to add to 6 to get 0? And that would be negative 6. If you're not sure, you can always set the denominator equal to 0, because we're saying x plus 6 cannot be equal to 0. And if I subtract 6 on both sides, that tells me x cannot be equal to negative 6. So you can do that work if you want, or you can probably just do it in your head and realize that x cannot be negative 6. So I do not have an extraneous solution because I got x equals negative 10. So it's not negative 6. Okay. All right, let's do another one like this. So once again, I only have one denominator in this equation. I've got x minus 7 for both of my terms, and then negative 4 has a denominator of 1. So once again, my least common denominator is just the denominator I see there, x minus 7. So I'm going to multiply everything by x minus 7 so that I can cancel out my denominators. So my first term, nothing cancels out because I don't have a denominator there. The x minus 7 cancels out in my other two terms. So now that I've done step 1 and 2, multiplying by my LCD and canceling, I'm going to distribute, or I'm going to first carry down what I have left and then distribute and combine like terms. So for the first term, nothing canceled out, so I still have the x minus 7 being multiplied with the negative 4. My next term, the denominator canceled out, so I'm left with 7. And on the right side, my denominator canceled out, so I'm left with x. Now I'm going to distribute the negative 4 to the x and the negative 7. So negative 4 times x gives me negative 4x. And negative 4 times negative 7 gives me positive 28. Carry down the plus 7 and carry down the equals x. Now I can combine like terms, my plus 28 and my plus 7. Those are both constants, so I can combine them. Bring down the negative 4x. 28 plus 7 gives me positive 35 equals x. Now I'm going to have to solve. So again, I want to get all my x's on one side. So again, I normally do like to move the x's to the left side, but then I'm going to be left with 0. So it doesn't really matter. I'm going to just move the x's to the right side instead. So I'm going to add 4x on both sides. So I get 35 on the left side, x plus 4x, that's like 1x plus 4x, so I get 5x. And my final step is to divide both sides by 5 to get x by itself, so I get 7 equals x. I'm going to write that in black. 7 equals x. So that's my solution. Now my last step, don't forget, I need to think if I have any extraneous solutions. So I want to look at my original equation. My denominator was x minus 7. We know x minus 7 can't be equal to 0, which means x cannot be equal to 7, because 7, if I plugged it in, 7 minus 7 would give me 0 in the denominator, which is not okay. So that means this is an extraneous solution. I got x equals 7, and that's the one solution I can't plug in because it'll give me a 0 in the denominator. So this is an extraneous solution. In the delta math, this means you're going to submit nothing, like you just submit no solution. Okay, I'm pretty sure that's how it works in the delta math from the examples I looked at. If you get an extraneous solution, you just submit no solution, no real solution. Okay, now example 3. This is like the second section of the delta math, which is solving rational equations with least common denominator or least common multiple. So with this, we're going to have a little bit of a different situation when we try to determine the least common denominator. So my first term has a denominator of 10. My second term has a denominator of 10x, and then 1 has a denominator of 1. So I really just need to focus on the 10 and the 10x. So again, to figure out my least common denominator, I'm always asking myself, what do I need to multiply each term by to get rid of the denominator? So I know that with my first term, I have a denominator of 10. So that means 10 is definitely going to be part of my least common denominator because I'm going to want to multiply that term at least by 10. And I have to multiply everything by the same thing. So the 10 would take care of that denominator. But then in my next one, I have a 10x. So the 10 I already was planning to multiply everything by would cancel out the 10, but then I would also need to multiply by x. So that means I'm just going to include an x in my least common denominator. So I don't want to multiply by 10 twice because that's just extra. I don't need to multiply by 10 more than one time. Multiplying by 10 will take care of the 10s, but then I also need to multiply by x to take care of the x. So now I'm going to show you what that looks like and why this works. So if I multiply everything by 10x, all right, the 10s cancel out here. I'm left with an x on top. The 10s cancel out here, and the x's cancel out, and then the 10x, I'm just going to leave that. It doesn't cancel with anything on the right side. So again, you could, like, hypothetically, you could multiply by 10 and 10x if you're thinking, oh, I need to multiply by 10 to get rid of this, and I need to multiply by 10x, but that's not the least common denominator. If I multiplied everything by 10 and 10x, it wouldn't be the least common denominator. It would be a common denominator, but we'd have an extra 10, and there's just no reason to add extra work. So I want the least common denominator. Since the denominators have the 10 in common, I know I need to multiply by 10, and then the second denominator also had an x. So I'm going to have to include the x to get rid of that, okay? So now 1 times x is what I'm left with here. Here, everything canceled out, so I just have 2x plus 7, and then 1 times 10x on the right side. So 1 times x leaves me with just x. Well, I don't really need to do that. I can just go ahead and combine my like terms. We know 1 times x is 1x. 1x plus 2x gives me a 3x plus 7, and then 1 times 10x is just 10x. Now I'm in my solving step, so I'm going to move all the x's to one side. So again, I don't want to have 0 on the right, so I'll just subtract the 3x to move the x's onto the right side. So I have 7 equals 7x. And then I need to divide both sides by 7 to get the x by itself. 7 divided by 7 gives me 1. So I get x equals 1. I want to think back to what would I not want in the denominator. For the first one, I just have a 10 in the denominator, so it doesn't matter what I plug in for x. I'm never going to get a 0 there because there's not an x in the denominator. But here, I'm saying the 10x, I would not want whatever I plug in for x to give me 0. And we can see that if we plugged in a 0 for x, that would be the only problem. If I plug in 0, you can just think of it as 10 times x, any number times x. If I plug in 0 for x, any number times 0 gives me 0. So anytime you see an x times a number in the denominator, it's going to be that we don't want it to be a 0. We don't want the x to be 0 because 0 times any number gives you 0. So of course this is not extraneous because I got x equals 1. All right, let's do another one like that. So I'm looking at my denominators. I have a 5, an x, and a 5x. Well, for the first one, I would want to multiply by 5 to get rid of the 5. So I know I'm going to need a 5. For the second one, I would want to multiply by x. So I know I'm going to need an x. And then for the next one, I have 5x. So I would want to multiply by 5 and x. Well, I already have 5 and x in my least common denominator, so I don't need to add another 5x. That means my least common denominator is going to be 5x. That's going to help me get rid of everything, all the denominators. So for the first term, the 5's cancel out. The second term, the x's cancel out. And for the last terms, the 5's and the x's cancel out. So 3 times x, that gives me 3x. That's what I'm left with here. And then I have 4 times 5, so that's going to be left with 20. And then everything canceled here, so I'm just left with 2x plus 9. All right, I don't have any more distributing to do, and I don't see any like terms. I'm just going to start moving. Now, again, I prefer when I can to move my x's to the left side, so I'm going to do that this time, since I wouldn't end up with 0 on the right side if I do that. So I'm going to subtract the 2x to the left side. If you subtract the 3x over to the right side, that would still be fine. So 3x minus 2x gives me 1x, which is just x, plus 20. And then I just have a 9 on the right side. Now I want to move the 20, so I'm going to subtract 20 on both sides. So I get x equals 9 minus 20 gives me negative 11. I had to think about that for a second. Yeah, that gives me negative 11. Cool. So that's my answer. Now I just need to think if that's going to be extraneous. So with this, again, the 5 doesn't, if 5 is my denominator for the first term, that's never going to be 0 no matter what I plug in for x. The x, we never want that to be 0, so that means x can't be equal to 0. And then same thing with the 5x. the 5x, it's just like before with the 10x. If I don't want 5x to be equal to 0, then x can't be 0, because the only way to get 0 there is if I plug in a 0, which multiplies by 5 and still gives me 0. So the only thing that I can't have here is I can't have x equal to 0. Okay, so this is not extraneous because x is equal to negative 11. Okay. All right, those are all the examples I have for you that should help you to do the delta math, and let me know if you have any questions.